Hello again, everybody. A small tutorial about schematics and wiring diagrams about the basics, horn circuits, brake light circuits, and as you'll see, if you know the fundamentals, the foundation, you'll understand the concept. You'll be able to analyze and troubleshoot for yourself. We'll begin with first two horn circuits over here. Try to make it simplify as I can, and please subscribe to my channel, Automotive Electronic Schematics from Joseph. Like I said, you'll find many wiring diagrams and also analysis of scan tool parameters, which is something new and fresh. I hope you'll enjoy that. First of all, the horn circuits. As you see, the switch, the ignition switch, by not knowing anything about circuits or knowing something minor about circuits, you always need a switch to activate voltage to something, to a load, to a switch in this case. When it says hot at all times, that means I do not necessarily have to have the engine running. As you see, there's 5 different positions available in the ignition switch positions. When you want to make contact or complete the path, as you see over here, if it's in the lock position, there is no connection. It's open. If it's in the off, there is no connection. The only time you have a connection is when this is in start. That means this one will move over. This one, switch will move over to this position. And in the run position, start is when you start the car, obviously, with the starter. Run is when the engine is running without starter, after the starter has engaged the transmission. Not the transmission, I'm sorry, the engine. The flywheel to the engine to get the crankshaft going and all that. So, start and then run. As you see, there is a connection from here to this relay. This is called a relay. The other one is, as you see the pink that I drew, accessories. That's when you don't have the engine running. You put the radio on or the lights on, and that will also give us a path. So any of these 3, start, run, accessories, will give us a path of current flows to activate the relay when we hit the horn switch, which is on the steering wheel. We know from actually all the videos that I made, a relay means you have a coil that's energized when current flows through it. Therefore, it creates a magnetic field. The magnetic field will activate an armature, a switch, from one position to another position, from a rest position to the active position that we want it to go. Therefore, as you see this dotted line, for all of you that are not familiar with relays, that means once we have current flowing, and remember current flows, voltage does not flow. We have a potential of difference between 2 points called a voltage, which is 12 volts. But voltage does not flow. Current flows as a result of voltage. That's why I refer everything to current. Current flows here. A magnetic field is induced, energized. This will now take this horn circuit. When this horn circuit is closed, I have a path, a closed path, a complete path to ground. Therefore, current can flow in any position that the switch is in that we spoke about. Accessories, run or start. Once I close this switch by activating it on the steering wheel to ground, I close this part of the circuit. I energize this. This takes this switch and now toggles it to this position, closing this side of the circuit. So therefore, current can now go, again, from a fuse that's 15 amps, which is not much. That's all we need to activate. Now it's in this position. So therefore, since this is in this position, and I'll draw it in, see? Now it's in this position, it's closed. Current can flow from this part of this branch, this is called a branch, and this branch of the circuit. These two are called in parallel. Parallel means we have two horns. That means the voltage will be the same at any point of this circuit. Whether you go here, whether you go here, whether you go here. It's a parallel circuit. All voltages are the same. It's the same connection. Therefore, the current will divide for one horn, and the current will divide for the other horn. So therefore, we activated the relay by pressing the switch on the steering wheel. That activated current to flow to these horn circuits, sounding both horns. Let's troubleshoot now, since we understand the basic concept of it. I go to the switch on the steering wheel. I press it. Nothing happens, which is the usual case. Many times it happens. Is it the switch? Is it the ignition switch? Is it the fuse? Is it the relay? Is it both horns to be faulty? Let's take each step by step when you troubleshoot. As I said, I've been a technician in electronics for 25 years, and you have to go step by step. First, you understand the concept, then you apply troubleshooting. Now, let's see. We have to measure voltages. What's the best way? Where can you start measuring the voltage? That will tell you in one step if all the other components are good in one shot. Well, I could do the logical thing over here. I can go over here and say, okay, this is 12 volts over here. Once I activate this, this is not 12 volts anymore. This will be 0 volts. Why? Because it's connected to ground. If it's not activated, this will be 12 volts. If I get 12 volts over here, that means I am connected through the switch to the battery. I try 3 different positions to see if I get 12 volts. I will try run, I will try start, I will try accessories. All of these positions, I should have 12 volts here, telling me that this is connected and the ignition switch is working. Remember, 3 different positions, I should all have 12 volts. Now, if I put my meter over here, at the other side of the relay, we'll call this 1, we'll call this 2. If I go to position 2 of the relay, I should have 0 volts, like I just stated over here. Why? Because it's connected to ground. The whole voltage drop will be across this relay. And I have to press the switch, obviously. If I press the switch, and I go over here, and I go to side number 2, and I measure 12 volts, that means this is open. But, as I asked the question, what's the best way to measure everything in one shot? Well, for me, the best thing is to go over here to this part of the relay to measure 12 volts. When I measure 12 volts over here, if I do measure 12 volts in one shot, that tells me the fuse is good. That tells me that this coil has been energized. That tells me that this horn switch, when I press on it, has been connected to ground. That tells me that the ignition switch is fine in working order, because once this is activated, current flows, and I have 12 volts in one shot. If I have 12 volts over here, that only leads me to tell me all of this circuit is working. However, there's a problem over here. Maybe the grounds opened up. It's possible if they have the same ground as you see over here. So let's take it in another sequence. 0 volts. I come over here and I measure 0 volts instead of 12 volts. So in one shot, I know, you know what? That tells me, okay, maybe there's a short to ground. If there's a short to ground, maybe this wire is touching this wire. Possible. That could give me a short. Remember, this is parallel circuit. If this is shorted, this is shorted. Keep that in mind. If this is 0 volts, another theory. That means this fuse could be open. But the other alternative is, in troubleshooting, this was not activated. This is open. So, if this was not activated, I would have 0 volts over here. If this fuse would be open, I would have 0 volts over here. Let's go back over here. We have to go over here and measure 12 volts. We have to go over here and measure 0 volts. If we measure 12 volts over here, that means we are connected. But that doesn't mean this is energized. It only gets energized when this is completed to ground. Therefore, if we go 12 volts over here and we measure 0 volts over here, that's normal. That means the problem is somewhere over here. Could be the relay, could be the fuse, could be there's a short from here to here. That means this over here, violet, black wire to this brown wire might be shorted. Therefore, I hope that was informative and helpful. That's how you troubleshoot. So remember, again, if I measure 12 volts here, that means everything is working, including this circuit, in one shot. If I measure 0 volts, that means this might not be connected because this is not energized, because this might not be energized, because the switch might not be good. Fault by fault you have to go. Of course, the fuse. Therefore, thanks for watching, and I'm going to have another one over here, and I hope this will be helpful also. Same idea over here. Now, we know when you're on the brake pad, we activate a switch. We activate a switch, and then the brake lights in the back are illuminated. Also, if you have in the window, usually the back window, you have a module or a strip, those lights also will be activated when you press the brake pad, the switch, which goes to a switch. Therefore, in this case, let's start hot and run or start. As you see over here, not really a relay, but a switch over here. Almost like a double switch. There is a transmission control module. Why? Because when you're on the brake, it tells the transmission control module you're probably in park or you're probably in neutral. It knows the gear that you're in. So, once I'm on the brake pad, I'm activating a switch, closing this circuit. As you see, the pink is now here. Therefore, it looks like this one will also be activated. How will I know that? Well, the idea is the light switch is closed. Therefore, I need the brake lights to be illuminated. Therefore, out of common sense, if this switch is closed, that means that this has to be also closed to complete the path. Therefore, current will go from the fuse. It will go over here. It will divide. Some current will go here. Some current will go here. Some current will go high-level stoplight. Could be the window. In the back window, there's another module, like we said. Anything. So therefore, now we go over here. Hot and run or start. Well, if you're in hot or run, this will be activated. But also, you don't even need a key in the ignition switch. You could just step on the brake and activate a switch. However, in this case, you do need it because there is a module involved and there is this switch involved. So therefore, once I press the brake pedal, I'm in park or neutral, I activate this switch. This has a complete path to ground. Therefore, this is activated. This switch is now in this position, closes the path, and now we have 12 volts across each one. How do I know I have 12 volts across this? Because these are all considered in parallel. We just said in the previous example, parallel circuits, all voltages are the same at any point. I go back over here, let's troubleshoot. 12 volts here. Oops. 12 volts here, 12 volts here. Therefore, we come back over here, 0 volts. I press the brake pedal. Both lights are not going on. The light in the back window, so to say, is also not going on. Okay, right away I think to myself, a fuse, is it possible? Of course it's possible. But what am I going to do? I'm going to go to this light switch if I can find it. I'm going to measure first over here if I measure 12 volts. If I measure 12 volts, that means I'm connected. That means when I am on the brake pedal, I'm activating the switch. So I have 12 volts over here. Could be, like we said, maybe the ground opened up or it's high resistance. It's all the same ground over here. Unlikely for all 3 bulbs to be out. Now, next example, I measure 0 volts. 0 volts means, of course, the fuse could be open. This is in this position, in the open position. Why is that? Maybe because the switch is not good. Remember, we said we need the switch to be activated to activate this for the lights. Once I measure 0 volts, that tells me, okay, problem could be here. Problem could be here that this was not activated. Problem could be in the control module. So we go over here.